notice actually helps me to make it more contextual for you. Okay. So you send me what you want to learn. So coming back to the leave plan that I have. So next week I'm not here. The week following that I'll be back. So the next week I'll be here. So next 2 days after tomorrow you will miss. But what I'm planning to do is I will do it online. Now when I do it online for you, it will be a very odd time for me actually. In India, it will be like 1:30.
You can change the time.
Yeah, that's what I'm thinking. That's why I'm asking her.
Evening
If
time is it fine?
evening, will it be okay?
Your morning time.
Yeah. So my other classes, like the 4 to 5, all the class I'll move by an hour. If I move it by an hour, that becomes from 5 to 6, which will be like 3:30 to 4:30 here in India. 6 to 7, the other one. And can I do 7 to 8 for you?
Yeah.
Should be okay? Okay. Then we'll do 7 to 8 for you. And there's one more student who is going to join this group, probably from beginning of May. Let's see. Because I want more students in the class because that's when it's called community-based learning. I mean, you will ask some questions, we'll answer, he will learn. He will ask some questions, some topic that he would want to learn, he will learn. And then a lot of exchange of information also happens when we do in a group. So that's what we'll do. So I sent you a message yesterday, not to you, in a group, right? In the Telegram group. Can you tell me what are the topics that I have mentioned there? It's called Problem Solving in Data Analytics. That's the name of the chapter, Unit 2 for SAT. Inside that we have a lot of subtopics. Let's go through them one by one and see what we know versus what we don't. I have taken a print out. Where did you keep it? Oh, it's here. There are two bundles here. Can you arrange them by the page number? Give one to me, one for yourself because on the back side you will see 10 out of 10, 8 out of 10. Let me not bother you. It looks okay. Are they two different bundles now? We'll see if something goes wrong. This is okay. Yeah, this is right. Yeah, this is better now. So, yeah, okay. I think should be okay. Yeah, you give that to me. This first. Okay. So the topics that I mentioned that we are going to learn today, this is unit 2 of the SAT syllabus. If you see, it's called Problem Solving in Data Analytics. Did you get a chance to see that in Khan Academy you have that digital SAT preparation? That is the entire syllabus. This is the second unit of that syllabus. Okay. Okay. So let's start with the basics, and then what I've done is I have taken up, noted down the questions also, that we, some sample questions that we'll try solving, so that we would know whether the way we learn things here versus the question that we have to solve, how close are they. Okay? So let's start with the first one: ratios, rates, and proportion. Okay. Okay. So ratios, rates, and proportion. I don't think there'll be a lot for you to learn, because this is something that is not one of the difficult topics here, but conceptually, I mean, there should not be any gap. So let's look at the ratios first. When you look at ratios, there are two types of ratios. Before I go there, let's say we have a bag of fruits which has 5 oranges, 10 apples, and 5, let's say, grapes is, 5 grapes is not right. Let's say we have 5 bananas. So total we have 20 fruits, 5 are oranges, 10 are apple, 5 are bananas. So you'll say, what is apple to oranges ratio? Apple to oranges ratio 10:5, or you can apple to oranges, 10:5, or you can write this as 10/5, 2/1. So for every every orange you have 2 apples. This scenario is called part to part. So this is one part, this is one part, this is one part. Second option is part to whole. So here you will say when you say part to whole, you will say oranges versus total number of fruits. So 5/30 or 1/4 is your oranges ratio, oranges to whole. Apple to whole will be this, 1/2. Banana to whole will be 5/20, 1/4. This tells you, out of the entire quantity that you have, what part is a certain thing in that group. Let's say in your class there are, let's say, 15 boys and 22 girls. So what is the ratio of girls? You'll say 50/37 in the whole class. Girls to boys ratio, this is boys, this was girls. Okay, so what is girls ratio? You'll say 22/37, meaning 22 by the total. When you say girls to boys ratio, it will be 22/50, right? So this is part to part, this is part to whole. This you know already, I'm just doing a recap. Here, this ratio extends to calculate percentage also. Yeah? So let's say in this community, let's say there are 20 houses. In this road, let's say the street, let's say 20 houses. Out of that, 7 to 8 houses are occupied or purchased by the people from Asian community. So what is the ratio of the Asian community in this street? You will say 8/20. And this is part of the Asian community, this is the whole. Yeah? So part to whole ratio, this 8/20. And if you want to convert that into percentage, you will just put this number. So percentage is also another topic, but we are just covering part of it here. Conceptually, you don't see any issue with this, right? This is pretty straightforward. Yeah. But interestingly, in SAT you will see this is one of the topics as well. So to me, SAT, whatever syllabus I have seen for you guys, this is nothing but a recap of everything that you learned from, let's say, 3rd grade all the way till 10th grade. And this is a summary of that. So basically, it just makes sure that everything that you know or you have learned in math, everything gets covered here. Because they are relatable also, right? I mean, when you are looking at ratio, you are seeing percentage also come into picture. Yeah. Now proportion. Ratio proportion looks or sounds very similar, but there is a small difference. How do you relate proportion? Do you do baking? Do you make cakes? Yeah, you know. So what is that you keep in mind when you are making, let's say, when you are baking, right? You know that I have to put flour, you have to put sugar, you have to put milk. If you are making with egg, you have to put egg, right? And there is certain proportion in which you have to put. You cannot say, okay, I will put 5 pounds of flour and 200 grams of sugar. This will go wrong. There is a certain relationship or certain proportion or order in which things have to be mixed to get the right taste or to get the right texture also. Yeah. So that is what is called proportion. Let's say if you are making tea, I make tea. So if I am making tea for 2 people, I will put maybe 1 cup of water and close to 1 cup of milk also. Let's say if I have 2 more guests coming to my place, I will not say that I will, okay, now 2 people at home and 2 people coming as guests, so 4 people, 3 cups of water and 1 cup of milk. This will go wrong. Taste will change big time. Yeah? So you will always say, okay, if I am making for 2 people, then I am taking this and this. If I am making for 4 people, what I am seeing here is milk and water is in the same proportion. So if I am making for 4 people, I will put 2 cups of milk, 2 cups of water. If I am making for 6 people, I will make 3 and 3. So this tells you, this is the proportion part, where it says one thing against the other thing. When we looked at the fruit basket thing, right? In the fruit basket, there was no proportion thing, right? You can have 20 apples, only two bananas and let's say 1 orange. Nothing goes wrong. Do the same adventure with this milk, you'll not like it. It kind of changes the whole plan or the taste or the quality of what is delivered, right? So that is why conceptually, when you have to represent milk to let's say milk to water ratio, you will say 2:2, 2/2 or 2:2. Looks pretty much similar to ratio, but the interpretation or the reason why we use this calculation is different. I've been talking non-stop. Any questions so far? No? Okay. So now this is the proportion. This is the ratio, conceptually. We'll see some sums and then we'll be able to evaluate whether what we know is working for us or not. Rates. What is the rate? So, your dad brought you here. He took, let's say, 20 minutes to come here. What did he do? How did he plan? He looked at what is the speed at which I can go. Obviously, take into account the speed limit and everything. He calculated, okay, on average, if I am going 30 miles per hour, that average, including the stops, including the traffic, including the speed limit. If I calculate 30 miles per hour and the distance from your place to this place is, let's say, 20 miles, then he knows, okay, I have to plan around 40 minutes. If the distance is, let's say, 10 miles, he'll say, okay, I have to probably plan 20 minutes. Yeah? So that 10 miles, if you say, that is a distance. If you are looking at the speed of your car, which is, you are calculating average speed, saying 30 miles per hour, that is the rate, where you are measuring one quantity against time. let's say you're preparing for exam, you will say, okay, fine, I have 10 chapters to cover. I have 5 days at hand. So 2 chapters per day. That is the rate. That is how you're saying 2 chapters is 1 unit that you're taking into account, but you're measuring that against time and say, okay, yeah. Every day if I'm studying 2 chapters, I'll be good with my goal of completing 10 chapters before the exam. Okay? So that is the rate part. Let's look at what is the definition I noted down just to make sure that I don't tell you something. See, quotient of a ratio where the quantities have different units, right? Like I was saying, 5 miles per hour. The nominator 5 miles per hour or 30 miles per hour or 2 chapters per day. Look at this. Look at this. These are different units. Yeah. Let's say I can drink 5 cups of tea a day. So that is my efficiency when it comes to drinking tea. That's how I'm measuring my efficiency with respect to drinking tea. So I'm saying 5 cups per day. Cups is 1 unit. Day is another unit. Day is the unit of time. Yeah. Cups is the unit of liquid volume. Yeah. So there are 2 different units that we are talking about. So whenever you talk about rate, you are always talking about 2 different units. So be it in terms of speed, be it in terms of your efficiency, be it in terms of your productivity, be it with respect to any plan that you make where we are talking about something against time. Mostly it's against time. Okay? So that's what gives you the rate. Let me stop. Yeah, tell me. Any questions? No. So, in summary, whenever you talk about rate, ratio and proportion, they look pretty similar. They might look confusing also. If you want to look at it from a day-to-day usage point of view, because that's how I want you guys to learn math. Don't learn math as a subject which bothers you. Learn math as a subject that enables you to do your things better in a more efficient way. So when we are talking about ratio is ratio, one thing against something else. Be it one thing against something else, or be it one thing against the whole. My number of members in my family against the number of people in the society. That is part to whole. Right? I'll say number of people in my family versus my neighbor's family member count. That is part to part. Very practical example. Now, look at proportion. You make cake, you make rice, you make pulses, you make curry, whatever. Yeah. Assume we making a curry by putting onions. 1 pound of, let's say I'm making potato curry. Only potato and onion. Okay, and spices. If I put 1 pound of potatoes, obviously peeled and cut potatoes, and if I put 3 pounds of onion, that will be a different vegetable than what we used to. Yeah, different curry. Similarly, if we end up putting salt, let's say half a pound of salt in a curry, which is probably total volume is 4 pounds. If you put half a pound of salt or 1 pound of chili powder, things go down. That is where proportion comes into play, where you need to know that one thing against something else has to be put in with a certain relationship in mind so that it doesn't go wrong. That is where a good cook or a cook like me comes into picture. Yeah. So that is proportion, and that is very much relatable. I mean, you don't have to trust me or anything. I mean, you know it already. You do it for a living. Let's say when we buy let's say even a cosmetic, the cosmetic that is made of either herbal products or something chemical, right? Both. You see it doing or having side effects or reaction when the proportion goes wrong. If they put one thing in a different order or bad order or in a higher quantity which is not supposed to be. Have you eaten pan beef ever? Pan? Have you heard of pan? So par, there are two three things that you put, right? So I don't know what you call that in English. In Hindi we call it chuna and katha. Chuna is like lime soda. Lime soda, no, not lime soda. The white thing that you rub, right? So if you put that more, what happens is it gets you scratches in your tongue, right? So that is where that's another example.
Sunam.
What is that called?
Lime only.
Uh-huh.
It will be in Tamil language. It's called Sunam.
Okay, yeah. So that
Salt they will add supari plus calcium.
calcium thing and then the white thing, right? Yeah. So what I'm saying is these are the practical examples that we come across every day. If you don't use certain things in certain proportion, you always know. If I'm making a big bowl of biryani, there's a certain proportion which I have to put rice, ghee, spices, vegetables, meat, whatever you are making it with. Yeah. So that is the part of it. This is not, you're not learning any math. You're actually learning how to implement things which are practically used almost on a day-to-day basis. And now when you're talking about rate, that is the interesting part. Something similar, but the units are different. Mostly we say that okay, we keep the units similar. That's how. Let's say if you have to add 5 pounds with 2 pounds, you'll say okay 7 pounds. Units are same. If somebody says okay add 5 pounds with 2 kilograms, units are different, right? So you have to convert and then add them. But then here, this rate concept is the only thing in math that you will see where you are dealing with one value which has 2 different units that you are dealing with. So mostly it's against time, or mostly it will be time. We'll see what all we come across. Okay. That is the first chapter. We'll have some sums about that down below. But if you want to close your eyes and just think through it and let me know if there's something that I'm missing here. We'll try catching up on that one before we move on to the next chapter, which is unit conversion. No? Okay. Now this one is, I'll be honest, okay? So I have grown up using metric system like that. We use kilograms, grams, kilometer, meter, liter, centimeter and all. Here, after coming to US, we got exposed to something called US customary system. That's what you guys have seen more than us. Yeah. So we will learn about the different kind of units, see what all I can teach you, what all you can teach me also. There are things that I would not know, which you would know better because you have used it more often. Okay. So in summary, we talk about 2 systems. One is called metric system and second one is called US customary system. And all this you have already learned. Interestingly, as part of SAT, you will see that there will be crisscross between these 2 units. Okay? And many places you will be asked to convert from metric system to customary system or vice versa. So let's try understanding how do we do conversion within the metric system and customary system or between these 2. Okay? That is what we are going to primarily learn. So, there are 3 main things that we talk about. We talk about distance, we talk about time, and we talk about volume. Time, distance, and volume. Okay? So, and volume. Now, when you look at time, we have learned seconds, minutes, hours, days, weeks, months, years, decades, century, whatnot. In the metric system, okay? Interestingly, this is something that is still coming to use, because as per the US customary system also, you use the same units: minute, second, hour, day, week, month, year, decade, whatnot. Yeah. So everything is same. Good thing is there is some amount of relief. We don't have to worry about the time part. It's the same in both the units or both the systems actually. Okay. Yeah. With me? Okay. Do you need water or something? No? Good. Okay. Now because it's post lunch time, right? So I know it's not easy. So time part we don't have to worry about. We just learn it once and that remains valid for both the systems. Now let's try remembering a song. So the song goes like this: milli, centi, deci, meter, deca, hecto, kilometer. Okay. So this is the advantage that you have with. Which is this one more thing. Weight. I was missing the weight part. Okay. So you look at distance where you talk about. Here we talk about inches, foot, yard, mile. In metric system you talk about millimeter, centimeter, decimeter, decameter, hectometer, kilometer, whatnot. Okay. Depending on what you are trying to measure in terms of distance. If you are trying to measure the distance from here to here, you will use a centimeter or maybe maximum meter. If you are talking about measuring distance from your house to this place, you will measure that in kilometer or miles. Yeah. So this is a sum. Milli, centi, decimeter, deca, hecto, kilometer. And this is the formula that helps you with all the three things: distance, volume, and weight. Milli, centi, decimeter, deca, hecto, kilometer. This is a song that I memorized almost 40 years ago. It is still helping me. So here, when it comes to distance, in the same song, you will put a meter. Okay? So millimeter, centimeter, decimeter, meter, decameter, hectometer, kilometer. Now, before I go further into it, this part should be clear anyways. You might not remember every step of it, but just at a high level. This might be a familiar thing, right? Nothing new. Yeah. So milli, centi, decimeter, deca, hecto, kilometer. Now here, when I talk about distance, I'm talking about meter. Okay? I will replace a meter here. So it becomes millimeter, centimeter, decimeter, meter, decameter, hectometer, kilometer. Okay? Now let's look at this. 10 of this. 10 millimeter makes 1 centimeter. 10 centimeter makes 1 decimeter. 10 decimeter makes 1 meter. 10 meter makes 1 decameter. 10 decameter makes hectometer. 10 hectometer makes 1 kilometer. So, if you are converting from here to here, then millimeter to decimeter, how many jumps you are making? 1 jump, 2 jumps. 10 into 10. So, 100 millimeter makes 1 decimeter. If you want to convert centimeter to meter, you already know that 1 meter is equal to 100 centimeter. But how? Because in this sum, there are 2 jumps that you are making. 1, 2. 10 into 10. So that gives you 100. Now, if in SAT, somebody says, how many millimeters is there in a hectometer? How many millimeters equals 1 hectometer? Okay. What you will do? Milli, centi, decimeter, deca, hecto, kilometer. Okay. So here to here, how many jumps? 1, 2, 3, 4, 5. So there are 5 jumps. So 10 into 10. 5 times 10. 1 jump is 10. 2 jump is into 10, into 10, into 10, into 10. This is the answer. 10 to the power 5. So 1 hectometer meter equals this many millimeter. So if you remember the sum, there's nothing else you have to remember, because you know that every jump is 10. Okay? If I have to convert this into a, let's say, decameter into centimeter, how many jumps? 1, 2 and 3. So 3 jumps. So 1 decameter will be equals to 10 meter. Every meter is equal to 10 decimeters. So multiply by 10, multiply by 10. 10 into 10 to 10, 3 times. That's how it will come into picture or come into play if you are converting a bigger unit to smaller unit. 1 decameter equal to how many centimeter? You are going this way. That is when you are multiplying. If you go other way around, somebody says, okay, 100 centimeter equal to how many? Let's say decimeter. So here you have to go reverse. You are converting a smaller unit into a bigger unit. When you are converting a bigger unit to a smaller unit, you are multiplying. When you are converting a smaller unit to a bigger unit, you are dividing that many times. Okay?
So small to big is dividing.
Okay, small to big is dividing, big to small is multiplying. Now, keep aside that thing. I don't want you to memorize anything. I want you to understand everything. Okay? So, scale here somewhere. I don't know. Okay. Now, look at this example. So far we have only memorized, we are talking about the metric system, and we have talked about the sum, millicentimeter, decahectokilometer. Okay. Now, if you look at the scale, okay, on one side you would have seen centimeter 1, 2, 3, 4, 5, 6, 7, 8, whatever. This is on this side you will see centimeter, and this side you will see inches. Yeah, inches are bigger than the centimeters. Yeah, you would have seen that. So if you look at a scale which has 30 centimeters, on the inches side it will be 12. So here, if you look at this is one, this is 2, 3, whatever. Inside that, what do you see? There are actually 10 lines. Every 2 centimeter distance is split into 10 parts actually. That is nothing but your millimeter. If you remember the sum, millicentimeter, decimeter, decahectokilometer. So this is 10 of the millimeter is making 1 centimeter. Okay. Now, what I said, if I am converting a big to small, I am multiplying. When I am converting big to small, meaning millimeter, centimeter, decimeter, meter, decameter, hectometer, kilometer. These are bigger units, these are smaller units. Right? If I am converting this to small, what I am doing? I am multiplying. Why? Now look at this. 1 centimeter has how many millimeters? 10. So 1 centimeter has 10 millimeter. Now, when the unit is bigger, smaller units have more numbers, right? To compare with that. What is happening here is, since you know that millimeter to centimeter is 10. Just 1 second. Hello? Hello? Class or not? Okay. So, you understand Hindi? Do you understand Hindi? No.
I understand this.
Huh?
I understand this.
Understand this. No, my wife called, so I was talking to her in Hindi. I was asking you, do you understand Hindi? Okay, alright, that was out of syllabus. So, come to this one. So, here 1 centimeter equals 10 millimeter. Meaning 10 millimeters together is making 1 centimeter. Meaning 10 small units are making lesser number of bigger unit. How? Because if you are converting from here to here, if you are converting this into this, what you are actually doing is you are actually dividing. That is how the number is less. Let's say if I have, let me give you a better example. If I have 1 centimeter, that is equal to 10 millimeter. 2 centimeter equal to 2 into 10 millimeter. 3 centimeter equal to 3 into 10 millimeter. Okay? Yeah? So, if I put it this way, if I have 3 into 10 millimeter equal to how many centimeters? What did I do? I divided by 10 actually. Yeah? So, when I am converting from a smaller unit to a bigger unit, my outcome will be less. I'm trying to force one understanding into your mind that you don't even have to think about it. Let me see how I can force that. So, 1 centimeter equal to 10 millimeter. Let me put it this way. 10 millimeter equal to 1 centimeter. 2 centimeter equal to 20 millimeter, or 2 into 10 millimeter. 20 millimeter equal to 2 centimeter. If you look at this two relationship, what's happening in this case? When I'm converting 1 centimeter to a millimeter, it becomes bigger number. When I'm converting bigger unit to smaller unit, it's becoming a bigger number. When I'm looking at smaller unit to a bigger unit, see this number is becoming smaller. So, for a quick solution or quick interpretation of what you will do, let's say somebody says 50 millimeter equal to how many centimeters? 5. What we are doing is, you can clearly see from this sum, decimeter, meter, decameter, hectometer, kilometer. So you always remember this sum and then you'll say, okay, I have smaller unit, I'm trying to convert into bigger unit. Okay? Smaller unit to bigger unit. Meaning it will be smaller. Meaning I have to divide. How many times? There is only one half. So I will divide this number by 10. And that is my centimeter. If I have to convert 5000 millimeter equal to how many decimeter? So look at the sum, millimeter, centimeter, decimeter. Okay, there are two halves that we are talking about, and we are going from millimeter to decimeter. Meaning, this will be whatever number I have, I will write it. I will say this is decimeter. Divided by what? 2 halves. So 10 into 10. Yeah? 50 centimeters, 50 decimeters. So when you are converting from smaller unit to a bigger unit, you are dividing. If you are converting from bigger unit to smaller unit, you are multiplying. Multiplying with what? That will be function of how many halves you are making and that many times of 10. Be it multiplication or division. So far? Okay. No, at times I myself don't get convinced about what I am teaching and am I reaching you or not. Okay. So I will keep questioning you just to get that confidence that yes, I am not just forcing you to believe me. Okay. Math is the only subject where you don't have to believe your teacher. You don't have to believe me. Okay. Many times you can do it by yourself and check and see if you have a reason to challenge your teacher also. Okay. So this is the conversion part. Okay. I'm just telling you how this song is going to help you with the conversion within the same unit. Okay. So we looked at only this is the distance part, right? I said in every system you have distance, weight and volume. Yeah. So milli, centi, decimeter, deca, hecto, kilometer, and millimeter, centimeter, decimeter, meter, decameter, hectometer, kilometer. This is the distance part of it. Now when you look at volume, you will replace meter with liter. Okay. So milliliter, centiliter, same sum, milli, centi, decimeter, whatever I was saying, I will just replace meter with a liter. So milliliter, centiliter, deciliter, liter, decaliter, hectoliter, kiloliter. So that is why this song is so very important. It might not be a hit song, but very useful song. Okay. So far, able to relate to this song so far? Now look at the weight part. You replace that meter with gram. So milligram, centigram, decigram, gram, decagram, hectogram, kilogram. So the suffix that you have here, that is the only thing that changes. Milligram, centigram, decigram, gram, meter, instead of meter you will have gram. So that's why I was saying this song is very much a universal song from a metric system point of view. So I will say milli, centi, deci. Here it remains little tricky. Deca, hecto, kilo. And since here it is meter, I will put a meter here everywhere. Here I know how to put meter, meter. So millimeter, centimeter, decimeter, meter, decameter, hectometer, kilometer. This is for distance. Same multiply by 10, divide by 10 approach. Okay. Now this kilo thing, right? Kilogram, kilometer, kiloliter. You might have known that okay, 1 kilogram is 1000 grams. Again, this song only tells you how many jumps you are doing from meter to kilometer. 3. So 10 into 10 into 10. This is what is 1000. So kilometer is 3 jumps from meter. Kilo of meter. That kilo is 10 into 10 into 10,000. So when you say kiloliter, kilo of a liter, again 3 jumps, 10 into 10 into 10. Kilogram is 1000 of a gram. That is because of 3 jumps, gram to decagram to hectogram to kilogram, 3 jumps, 10 to 10 to 10. So that is why that word kilo that we are so very used to, that kilo is nothing but 1000 of something, and that comes from this song. Whoever created this song for us, that guy was the creator of that theory, saying kilo of anything equal to 1000 of that. You would be knowing like kilobytes, megabytes, gigabytes. That is little different, but somewhat similar to this. But in terms of byte, it is 1024. But let's not worry about that. It's close to 1000. That's why it is. It again relates to the same thing, kilo. Okay. So only one sound whole metric system does. Okay. So milli, centi, decimeter, deca, hecto, kilometer. If you memorize that, you know about the distance, you know about the volume, you know about the weight also. And then time remains the same. So let's not worry about that. It's the same both places. Let me pause here. Any questions? Okay. So, was this information of any use? You can relate, right? Yeah. So, whole metric system is very easy. Yeah. Though Britishers ruled us for quite some time, but they taught us one system which is dependent on one song, entire system. Okay. For any distance, volume, weight, measurement. Now comes the system which we have been using for some time now. So that is called US customary system. So there's some interesting theory about it, right? So when again, it's going on YouTube, but there's no intent of creating any conflict. See, in US, what we have seen, whenever you go to India, you turn on the switch. What do? You press it down, it turns on. Here, what do? You press it up, right? It's just the reverse. And what I learned from people was that when after US became independent, they had the fear that Britishers will dump a lot of things from produce the things in their market and then dump it here. So they wanted to make sure that none of the things can be used as is, so that their own resources or their own system, their own development comes to their help actually. That's why we drive here on the left hand side. All the British cars, they drive on the right hand side. What we have in India, it is again mimicked from the British culture, right? So that's why we walk on the left hand side. Here we walk on the right hand side. Everything is just upside down. Okay. Same way here also, this customary system was again developed to make sure that the core of everything, the core of physics, core of math, everything is very different. That's why they developed this US customary system. I mean, more than 70% of the world uses metric system, but only in US and few other countries we use customary system. So, like I said, any system that you talk about distance, you talk about volume, you talk about weight, and you talk about time. Time is thankfully common, so we don't have to learn that. But when it comes to distance, weight, and volume, we have to learn that. So let's look at the distance part first. What do we use here? Start with inches, then go to foot, then we go to yard. Hey Tasmit, come sit down, take a chair, sit down. We'll start your class in 5 minutes. Yard, and then we talk about mile. Thankfully, this is the easiest of the lot. Okay, there are not so many things. 12 inches make 1 foot, 3 foot make 1 yard, and 1760 yards make 1 mile. 1760, right? Or 1740. Have I written it there?
I'm not sure.
Yeah. Okay. Yeah. We'll just we'll be done with this class in 2 minutes, okay? What is that? What is that? Sit down. Don't disturb the class. Let's go finish this class.
Yeah.
Sit down. Find a place, sit down. Okay. So, let's see if we remember. How many yards equal to 1 mile?
How many yards you go to? That would be 0.1760.
Okay, wrong question to wrong people. You guys have to memorize. We have learned this in the past. Guys, calm down. Calm down, okay? No, not you. I'm asking Arav and Ishan. Okay. So, okay. So, 1760 yard equals 1 mile. This is the relationship. Inches to foot to yard to mile. And this is something that we'll use only for conversion. When we talk about that. From within unit conversion or cross unit conversion, okay? From metric system to customary system or vice versa. Alright? So that we just started with this one. We'll talk about the other things in the next class. And then they don't remember anything. They have just learned it a few weeks ago. But yeah, we'll have to practice that. Okay? So let me stop it here.